Welcome to Netlabs Hub. Today I'm going to show you how to troubleshoot IPSec VPN on FortiGate Firewall. So at the end of this video, you are going to understand the steps you can go through to troubleshoot IPSec VPN either on simulation or a real network environment. So sometimes as a network engineer, you may configure site-to-site VPN, then the tunnels fails to show up or to be up. You need to think about it, what might be the issue and what might be leading to such issues. So the first thing, you have to verify connectivity. Confirm both VPN peers have internet access, or verify public IP addresses, then test connectivity, especially if LAN 1 from one side can ping the other. So to carry out this troubleshooting exercise on IPSec VPN, I'm going to use this particular previously configured lab. This lab is already on YouTube. You can watch to get to know how I approached it. This time I'm teaching you how to troubleshoot site-to-site VPN between these two sites. So step 1, as you can see here, we verify connectivity. Confirm both VPN peers have internet access. So to confirm that, we can just come here. You see DHCP, then this computer will get the IP address automatic. You see, it has received IP address automatic 192.168.11.20 from its specific subnet. So we try to ping Google. When we are able to reach Google, it means we can, you see, it's not reaching Google. So it means there is a big issue here. This one, first of all, to know the reason behind this, maybe a static route has not been created or a firewall policy to the internet has not been created. That's one. 2, you can check here, verify public IP addresses. So I'll log into my firewalls, then check. So this is the FortiGate Firewall in a site called Zambia. So first of all, I'll go to the network, then check the interfaces. So on the interface, you can see that LTK1, it has this is the public IP that the guide has instructed us to check. You see, public IP address. So on that firewall, the Zambia firewall has that IP, you can see, and it's upper. So this is the management interface. Then you can see the Zambia local LAN interface. You see, this is a mistake. The role has not been specified, so it should be LAN. You see, that's one of the issues that you have to solve. Then DHCP is enabled. Then this role status is up. So we are done on that. Let's check the static route. The static route is created here. You can see. This means that through the ISP interface, we can get to we can get to internet, you see. Then these are the static routes for the VPN tunnel, but so unfortunate you can find that this tunnel interface is down. So we will know how to troubleshoot that, but remote black hole is up. So that is the static routes is there. So the next we check on the firewall policy. The firewall policy, this is Zambia LAN. This is for the VPN. So we've got this rule, Zambia LAN to the internet. So our computer at the Zambia local area network should be able to ping to the internet. So that is how you check connectivity. We can use this execute, then we ping the public IP, execute, ping, then 192. Let's just ping the gateway. You see the gateway is reachable. If we can reach the gateway and it is not reaching the internet, the rule is there. The firewall policy is there. So we narrow down to the other issue, which might be the issue to do with the DNS that we've just pinged. So the next step, this is step 1. We are done with this step 1. So connectivity, it's not connecting. Next, verify the tunnel interface. Verify the phase 1 IPSec tunnel phase 1. Check the tunnel status. So to check the tunnel status, we'll just use this command, get VPN IPSec tunnel summary. So we'll just get to this file. Then we type this command, get VPN IPSec tunnel summary. So you see, Zambia, VPN Zambia to Kenya. It is operating under using this particular IP. Then the selectors, they are up. But you find that there is only one selector that is up. Then transmitted packet and received packets is total 0. So you see, we can verify that in the graphical user interface. So we'll just come to the VPN here, then IPSec. You see, the tunnel is down. Huh? You see the tunnel is down. So this tunnel is down. So we have to find a way of bringing this tunnel up. We can just right click, then bring it up. You see, the moment I have done so, it is still down. So we narrow down to another issue that might be leading to this error. So diagnose, let's take the diagnosis of the tunnel list. We just paste diagnose VPN IKey, even gateway. You see, this is the gateway 1, this is the IP, then it is passing through this. The tunnel ID is this, remote, you see, network, then so on that. When we come to Kenyan, the FortiGate firewall at Kenya, Let's check the tunnels. The tunnels are also down. So you notice that if the public IP gateway addresses are configured correctly, then still the tunnel is down. You've confirmed phase 1 and phase 2, they are still down. So we narrow to what we call pre-shared key, the authentication. We have to check with the authentication how our authentication is done. First of all, if the network is okay, you can see here, then authentication, we check the pre-shared key. For example, previously I used Fortinet. Fortinet is how many letters? 1, 2, 3, 4, 5, 6, 7, 8. Fortinet. Let me just write Fortinet here. Fortinet. So remember that pre-shared key should be the same on each FortiGate firewall that is used. That is 1. 2, remember also the version of the devices used in this particular regard is the FortiGate firewall. It should be of the same version between 2 sites. Between the sites, the firewall should have the same version, the same firmware status. The pre-shared key between it should be also the same. So I have checked the pre-shared key on the other side. So let me check this side. When we check this side, you see, it seemed that the pre-shared key, it was not matching. The moment I have just changed the pre-shared key to match what is in Zambia, phase 1 is up. So to make sure that this phase 2 is up, we just bring it up. We right click, then we bring phase 2 up. You see, now my VPN tunnel is up. This is how we troubleshoot the status of VPN tunnel. You can see. Now when I check diagnose VPN IT gateway list, let's go about it. Diagnose VPN IT gateway list. You see, now it's up. You can see the lifetime, the key, the proposal. This is the pre-shared key, the ID here. You see, phase 1 is up, phase 2 is also up, the remote is all. Then this is the tunnel ID. The tunnel ID is the IP address for that interface connecting to the internet as per that site. So you can see .163, that is for Liquid Telecom, this site. Then this site is for 101. You can see it here. So we are done on that. I have verified that phase 1 internet key exchange is up. So we can verify the remote gateway. I have shown you the remote gateway, the pre-shared key. Both versions, phase 1 and phase 2, is up. The aspect of encryption and authentication, that is where I used Fortinet as my pre-shared key. Then Diffie-Hellman group, then lifetime. During configuration, I just left it default. Then NAT Traversal is disabled, as you can see here. Let me show you. When you configure the VPN tunnel, NAT is always disabled. You can just check here. Then you see, NAT is disabled. On both rules, NAT is disabled. NAT is only enabled for that particular rule that allowed access to the internet. So once we do that, we check the verify phase 2. So phase 2, it deals with the local area networks connected. So local and remote subnets, are they well configured? encryption and authentication. So I will start with the FortiGate at Zambia. First of all, we will check that this is the subnet at the Zambia network. So it is 192.168.11.0. Then when we come at Kenya, we have 12.0. So let me start with this firewall here. So I will check from the interface perspective. From the interface perspective, this is LAN. You see, it is correctly configured. Correctly configured, we can see there. DHCP is enabled on that interface. When we come to the Kenya network, LAN subnet, that is the, you see, there is a mistake. This one, this interface should have the role as a LAN, but so unfortunate, when we try this computer here to check to get DHCP IP address automatically, it is giving us a failure. You can see it can't find the DHCP server. So we have to troubleshoot and get to know what are these reasons that making this particular computer not to access the server. One, that interface might be down, or generally on physical premise, the cable may be loose, or it's not connected, or the computer itself is down. So those are just possible issues. So in my case here, the cable is just okay. You see it's blinking green. So if it is green here, it means the cable is okay. My computer is up, but still it's not getting. So we narrow down to the server. So in this side, I'm using the FortiGate Firewall as a DHCP server. So I'll check. This is Kenya. Then you can see the DHCP server, it's not enabled on that interface. So we enable it. The moment we enable it, we save. So we try if at all our client will get the IP automatic. We repeat the same process. The moment you see DORA, it means that now it has accessed the DHCP server. You see, it has started 192.168.12.50, and when we check how is the server configured, just a minute, you see I have conditioned the server to start issuing IP address from 50. So it is correct. So it is correct. When we try to ping the gateway, that is the IP address assigned on the interface, you see it is pinging. So meaning connectivity to the server, it's okay. If this one is a failure, it means that it will not get the IP address automatic. So from here, we go to the next troubleshooting step. So to check the local and remote subnets, you just come on the VPN tunnel here. For example, this is I'm on Kenya subnet, Kenya network. You see the tunnels are up. So you'll right click on that, then you just check something here on the network. Phase 2 selectors. You see local address. So this is local address, this is VPN Kenya, then remote is VPN Kenya to Zambia. So it's okay. We can check here. We can edit it here. So the moment this is pre-shared key, yes, it's okay. So the subnets are well configured. The subnets are well configured. So we move to the next troubleshooting step. So for example, here we can choose ENC means encryption, then DEC it means decryption. So we can check diagnose VPN tunnel list. So we'll just come here, then diagnose VPN tunnel list. You see? Then we search for ENC encryption. You see it has encrypted 8 packets, then decrypted. You see? So that is it. It's okay. Then the next, we check the routing. We check the routing now. You see, at this point, this computer is able to ping this particular IP here. Also, this one is able to ping this particular IP. But this one is unable to ping the Google DNS. Let's try this particular interface. So the gateway, this is the gateway here. So ping 192.168.122.1. You see it's pinging. So it means it is able to reach the internet. It's unable to ping this because the DNS is not specified. So let me try to specify that DNS. To specify that DNS, you just come on the LAN interface. Then on the DNS, you specify here. Then you can add, this is Cloudflare DNS. Then you save. Let's now try. Still, it's not accessing that. So this one has received 11.20. Let's try to ping 192.168.12.50. So you see, this is the IP for the computer in the Kenyan local area network. I hope this is the computer that I'm pinging, you see. So there is connectivity in that this site can communicate comfortably with this particular site. So now when I check the encryption status, I should see the packets that are encrypted and the packets that are decrypted. So when I try to return this, you see here, you see this particular PKTS, that is, those are packets, then /bytes. So you see 72 has been decrypted, then encryption, it has been done, you see. It has been done. So it's okay. We've verified that indeed our packets. So this is the flow. When traffic moves from this particular PS3 to the destination, that is the Kenyan site, it will pass through this tunnel. It will not pass through the internet. And that is why this computer is unable to ping the internet. And that it's unable to ping the Google DNS because Google DNS is found on the internet here, but we've created a traversal rule here, at least to secure our traffic, so that this Liquid Telecom here and Airtel, the two ISPs, are not in the know the type of traffic that is being transmitted here. So next, routes exist to remote network. You see, I have demonstrated that packets can ping. You see, I'm pinging the computer at the Kenyan site from the PS3. PS3 is at Zambia, is in Zambia. You see, I'm pinging this particular traffic from here, sending traffic from this computer up to this computer. So through this particular interface. So that one means that there is connectivity. It means that these rules have been met. Firewall policies to allow LAN to the VPN, it's okay, and that is the rule. You can see this is the rule, that is the LAN through the VPN. You can just come in and I show you here. This is the rule that is allowing traffic Kenyan LAN to VPN Kenya. So this is the tunnel that is using, you see. This is for outgoing traffic, then this is for incoming traffic. If we want to check that, we can check events, then VPN events. You see, initially when I was troubleshooting, it was negotiating. The moment traffic is passing, you see, the tunnel is up. The tunnel is up, phase 2, phase 1 is up. Then, you see, it is passing the traffic. So these are the logs. We can delete these all logs, execute, delete, execute log, delete all. The moment we delete all these logs, then we come on the VPN site, IPSec tunnel, then you see the traffic is passing through the tunnel. So I want to bring down this particular phase 2 selector. So the moment I bring down, then I refresh. Entire tunnel, I can just still bring down the entire tunnel. You see the tunnel at the Kenyan site is down. So once it is down, you see there is traffic drop. So now traffic is going through the internet. Let's check the events. The events, VPN events. You see, tunnel up success. So that is it. Let's bring again our tunnel, because it is operating on auto negotiation. The moment you bring it down, the tunnel from the other side will force it to be up still. So we can go back to events, then check the routes. Events, so the next thing, address objects are correct. So the moment you can ping from one side to the other, it means that the routes exist, and then the firewall policies are correctly configured, then the NAT is disabled for the site-to-site VPN, especially on tunnel interfaces. So after there, verify the tunnel list, diagnose VPN tunnel list. I have shown you that. The moment you see states up, it means that tunnel is established. So we can these are just diagnosis commands. We can just take that one, then try to see. So I'm debugging, it will start showing. So on that, as I wind up, let me draw your attention to the issues that cause IPSec tunnels or site-to-site VPN not to function. One of the first issue, it might be that the forwarding policies have been denied or denied by forwarding policies. Remember that when you create the outgoing firewall policy, you should also create the incoming firewall policy. Especially this happens when you set site-to-site VPN using the manual template. So also next, there is no matching policy. If at all a match is not found, the firewall drops the traffic. If the route is not existing, there is no existing route, the traffic fails to trace where to go through. So always check the route, check the matching policy, and also check the firewall policy. So I have stated here symptoms, a symptom and the likely cause. So for example, what happens when phase 1 is down? When phase 1 is down, incorrect pre-shared key, as I had just showed you earlier, because I had demonstrated this, whereby this site was having a correct pre-shared key, then this site was having a different pre-shared key, so the tunnel was not negotiating. So when phase one is down, check the pre-shared key, check the version that you picked on the internet key exchange. When you picked version 1 on the first site, also pick the version 1 on the other site. Next, check proposal mismatch. The proposal must match. Tunnel do. The tunnel interface. Here, when the first 2 is down, then also check the selector. Selectors here, I mean the local and remote subnets. You cannot use the remote subnet, then configure it as a local subnet. It will not work. When the tunnel up and there is no traffic, concentrate your troubleshooting muscles or strength on the routings. Check the routes, then check the firewall policy. Ensure that on the IPsec tunnels, NAT is disabled. When the tunnel is flapping, so when the tunnel is flapping, these are issues to do with maximum transmission unit. Maybe the maximum transmission unit is, the threshold is met or is set manually to a specific. So check that. If there is no response at all, you have to test the peers. The peer, if it's reachable or unreachable. So to summarize on this, connectivity, for you to having configured site-to-site VPN, for you to realize both ends ping each other, ensure that connectivity, first of all sites connect to each other. You can ping from one side to the other. 2, ensure that phase 1 is up, phase 2 is also up. Once the 2 phases are up, go to the routing. Ensure that there is a route that defines how traffic flow from site 1 to site 2. Also, in respect to the firewall policies for outgoing and incoming traffic. Once you do the routing and firewall policies, then the tunnel status, you expect them to be up at this moment. So once the tunnel status are up, you can test by sending traffic, then later debug. As you can see on my side, traffic, this is the testing stage. So that when we come to this particular firewall at Zambia here, we can check the tunnel is up. When we click here, you see, when it is blinking like this one, it means when it blinks like this way, it means that traffic is passing through the tunnel. And indeed, I'm pinging the other side from Zambia. Zambia is pinging to Kenya. So it means a computer at Zambia, in Zambia, is pinging a computer in Kenya. It's sending traffic. That's why you see the tunnel is active here. And you see traffic is passing. It was 39, right now it is 41. There is no drop. So thank you so much for following this particular troubleshooting lab for IPSec Site-to-Site VPN on FortiGate Firewall in GS3. So this is a simulation that I hope it will help you to troubleshoot real enterprise network in this scenario. Thank you. Feel free to subscribe to Netlabs Hub for more videos. Thank you.